honestly, the reality is I forget solid principles all the time, what they all mean. So let's look at the solid principles, and then I'm going to explain why I'm triggered, and I'm going to die on the inside, okay? Here we go. The solid principles are the 5 principles of object-oriented class design. Okay, so I feel like I've already reached all the information I need to know, okay? Because we all know that I don't do object-oriented or functional programming. I do functional programming and object-oriented at the same time. F-poop, everybody's favorite, new. It's honestly, when it first came out, it was so hot. It's kind of cooled off a little bit since it came out. Not gonna lie to you, it's cooled off a little bit. Not nearly as steamy as it once was, but we're working on it, okay? Let's see. These 5 principles help us understand the need for certain design patterns in software architecture in general. So I believe that it is a topic that every developer should learn. This article will teach you everything you need to know, to apply solid principles to your projects. We will start by taking a look into the history of this term. Good, that's what I need. Then we are going to get into the nitty-gritty details, and that's why. Okay, so this is why I have something called I just make up words. I have makeup worditis. The whys and the hows of each principle by creating a class design and improving it step by step. So grab a cup of coffee or tea and let's jump in. The background. The solid principles were first introduced by the famous computer scientist Robert J. Martin, aka Uncle Bob, in his paper in 2000. But the solid acronym was introduced later by Michael Feathers. What a lovely name. The name is Michael Feathers. You wouldn't understand how silk my silk blouses are. Anyways, Uncle Bob is also the author of best-selling books Clean Code and Clean Architecture, and one of the participants in the Agile Alliance. Feather. The name's Feather. Michael Feathers. Therefore, it is not a surprise that all these concepts of clean coding, object-oriented architecture, design patterns are somehow connected and complementary to each other. They all serve the same purpose, to create understandable, readable, and testable code that many developers can collaboratively work on. That's a good principle. I mean, honestly, like, this is a good North Star. I do agree, like, this is the North Star you should have. We should all have that, right? Base Paint Dev, thank you for that. Let's look at each principle one by one, following the SOLID acronym: single responsibility principle, the open-closed principle, the Liskov substitution principle, the interface segregation principle, the dependency inversion principle. Solid. I'm glad they didn't choose ArcC, because they could have chosen ArcC, right? I mean, it's right there. Is right there, right in the name. All right, anyways, the single responsibility principle states that classes should do one thing and therefore should have only one single reason to change. Or all TTTs. Oh yeah, it could just be a bunch of T's. We could have had the 5T. T5. T5 stack, anybody? Who wants the T5 stack? All right, to state this principle more technically, only one potential change, database logic, or logging logic, and so on, in the software specification should be able to affect the specification of the class. This means that if a class is a data container, like a book class or a student class, and it has some fields regarding that entity, it should only change if we change the data model. I also assume this means like some of the logic around the data model, like you could imagine. The following the single responsibility principle is important. First of all, because many different teams can work on the same project and edit the same class for different reasons. This could lead to incompatible modules. So I always have kind of like, I generally have like a kind of a problem, if you will, with this. So let me just open up this hot mess that I have of a code base. So you'll notice this little guy right here. Now you're probably thinking that can't be that hard to do that, right? Well, actually, to create this little square and to do this, it takes a lot of effort to make this coloring work. Okay, it actually took an unusual amount of effort, I must say. Not simple, right? But to make it done, we broke it up into a couple different kind of, if you will, modules, classes, however you want to call them. They are actually tables in Lua. So I have something that opens windows, that creates a new display cache and new color set. So in some sense, I did kind of create the single principle kind of idea that this thing just does the displaying. This thing just does the color setting, right? And so you kind of have to apply them one at a time, right? Because if you try to update the display cache, it actually wipes out the extended marks, and therefore you actually decolor that spot. And so it makes sense. This is a good way to do things. You could have easily done this with RxJS. Yes, absolutely. Window opening and creation is like its own set of just things, right? It's just a bunch of code around creating and opening and listening and attaching and closing windows and all that kind of fun stuff. Okay. Apparently I don't even have this I'm not even using this function. Oops. But you get the idea, right? You get the idea. And so it's like, do I disagree with single responsibility? Not really. I'm just way more willing to be a little bit loosey-goosey. Do you know what I mean? So when I go back to app, it opens up windows. It closes windows. It also takes in commands from the TCP pipe and determines what to do. Should we render? Should we partial render? Should we close? Should we open up a window? And then alerts everybody else of commands. We also alert people of renders after we get done on rendering or partial rendering. So it's kind of like one of these things where I would argue that this isn't following the single principle logic, right? It's not very solid because it's actually really doing two things, right? It's not only listening and processing commands from the TCP, it also is interacting with the UI. Now, we could pull that out, we could do all that. It just takes a lot more effort to do that. So instead, what I thought was a little bit nicer, I just simply, oh my goodness, I forgot I removed all my stuff. I just created a quick little fake TCP thing that I could hand in, that I could read a bunch of data from a file and then just pipe in what's in that file into a TCP thing and call that a day, right? For me, that was nicer to test. It just is. It just is. Right? And I could make it so that any single one of my outputs could be then piped into a file and I can just replay the experience from the server over and over again. Better experience. I just don't think you always have to follow this principle. I think there's sometimes that it makes a lot of sense. And again, I break it all the time. I literally break this all the time for the purpose of just making something easy. Very simple thing. This display cache only does stuff about cache, right? It doesn't do anything until I do this, right? Render into. Now this is where I break the idea of single responsibility. It now actually, instead of just being the cache, I'll actually have the cache do the most optimized render into the window, like into Vim. This is totally breaking single responsibility here. I'm okay with that. Like I'm actually super happy about that. It makes life 1,000 times easier to do this well. Yeah, right? So I'm happy. Sorry, I had to remove those two. Those are from some debugging yesterday. Anyways, so there you go. That's kind of like my thoughts on these things, which is, again, this is why I don't adhere to the solid principle, because I often find that in real good programming, you have two choices. Choice number one, solid is for programming. You don't need it for scripting. Oh, okay. So like game engines are definitely, I get that. Yeah. I mean, I'm kind of script kidding this one out. You know what I mean? You're right. The man's right. Today I learned scripting isn't programming. Today I learned making a cached rendering interface on the front of a real-time ASCII engine is just scripting. I didn't know that. I honestly had no idea personally, but I mean I get it. I kind of am. I think I fall more under the jackass category than even the script kiddie category. Okay, just mostly an asshole. Anyway, so this is my big problem with single responsibility is that you have two kind of trade-offs you get to make when you do this. One, you abstract and invert control. Really, dependency inversion is kind of like, this really falls into the single responsibility principle. You either have to invert your dependencies, or B, you break some of these so that you can have locality of behavior. And so I choose locality of behavior often more than I choose really nice programming. And so this is a very good example, right? My cache going from a cache item into a rendering item just brought this locality of behavior really, really close. So I can understand exactly what it does without a ton of thought, without a ton of hopping around. And so I really, 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 really like that idea. And sometimes I just feel like you have to do that. Same with the app init. This thing that's processing TCP commands, probably don't need that, but it's just, it creates such a tight locality of behavior that it just makes it really simple to kind of work with. And so I think that you got to learn how to break that principle to get things done. And the other side of it is that you just have to abstract, right? You either have to choose abstraction or potential, or you're going to you have to choose either abstraction or locality of behavior. And sometimes locality of behavior makes things harder to test. They make them more brittle, so you kind of have to know when to abstract, when not to abstract. And so it's kind of a fun. That's why I hate giving like direct or required principles, because anytime you do something like that, you by necessity make things harder for people. It's almost like what you should tell people, hey, go out there and just build it. And they will go out there and they'll do locality of behavior and they'll do abstraction and they'll go on both sides and they'll just have this really difficult time because the first time you build something, you build just horseshit. Like you just build bad programming, and that's okay. That's step one to becoming a good programmer, is building bad programs. So then what's the next thing you got to do? You build it another one and another one and another one. And you do that for like 10 years. And you'll then slowly start developing kind of like an intuition into when you're supposed to break things. Miami killed your voice, yeah. For those that don't know, I was in React Miami, and I had to do like a live stream and talk to like lots of people. And then there was like parties, and they kept making the music loud, and I hate loud music for that exact reason. And so I lost my voice, and it's starting to come back. Anyways, so single responsibility principle, I don't necessarily shoot for it. It's not that I don't think it's bad. I don't make it a requirement, because if I do that, I'm going to be by necessity abstracting my code further and further and further, right? Because I would have like the best, I'd say the best one would be this render into. I would need some way to emit out a new data class that represents a set of changes that need to be done. And then I have to have something that takes those set of changes and applies it to the window, right? I'd have to like just add a little bit more, logic, but that's just one more place in which it's going to break. One more place to be wrong, one more place I'm going to need the test. Anyways, common pitfalls and anti-patterns. In this section, we'll look at some common mistakes that violate the single responsibility principle, and we'll talk about some ways to fix them. We'll look at code for a simple bookstore invoice program as an example. Okay, we have string name, blah, blah, blah. So we have like a little data class, right? We just have an object. And now let's look at, this is kind of for me, these are always this is very Java-esque though, writing of code, right? You can't just write an object. You can't write an object. You have to like write that kind of object. This is a simple book class with some fields. Nothing fancy. I'm not making fields private, so you don't need to deal with getters and setters. It'd be crazy to do that. Now let's create the invoice class, which will contain the logic for creating an invoice and calculating the total price. All right, we do in here. We have a private book, an invoice. That's kind of wild that you have an invoice for a single book. I'm just throwing that out there. You know, invoices sometimes have more than one thing on them. We have book, quantity. Oh, it's just book and a quantity. Crazy. What happens if you have more than one book? Anyways, you have this discount rate, taxes, okay, calculate total does all this stuff, okay, print invoice, fantastic, save to file, let's go. Now, this is what they're going to definitely be upset about this one, is my guess. Here's some, let's see, is our invoice class. It contains some fields about 3 methods: calculate total, print invoice, save to file. You should give yourself a second to think about what is wrong with this class design before reading the next paragraph. I actually think there's nothing wrong with this. I mean, this is probably not, I'm not sure if this is how I would design it, but this is good enough to me. Besides for the fact that you can only order one book and multiples of that one book, a little wild, but besides for that, I don't care about the rest of this. Indentation, a little poor. Yeah, I'd argue that you should get better indentation. Right, let's see. The first violation is the print invoice method, which contains our printing logic. Remember how I talked about the whole, render into, you know what I mean? Which contains our printing logic. The single responsibility states that our class should only have one single reason to change, and that reason should be change in the invoice calculation for our class. So this is where I just fundamentally disagree. I don't think you need to do more than that. I think it's just fine to have these kind of things on here. Like, I don't think you're buying or losing anything. It just depends on the size and the complexity of what you're doing. Right? Like, at some point, you may not want that. Right? And the problem is you lose this in these smaller examples. But if this was producing HTML, I'd probably want it produced elsewhere, right? I'd want it inside like a template, because I'd want something in which I can kind of control from the outside. Absolutely. But if I'm just making a TUI app, would I change it up to have it printed right here? Very potential, right? Very, very potential, right? Presumably, you'd want to inject system out as an input. Like, see, again, but that's assuming that you want to, see, this is the problem with, one of the problems I have generally with Solid is that you should test everything, right? I have a general rule of thumb, which is I test things I don't think I can get right on first try, or are easily screwed up by somebody that doesn't have the understanding of it. Should you test calculate total? that seems like a good place to be. Very easy, simple. Love the new voice. Shut up. Very simple, right? I just wanted to be Thor, so I just figured I'd go out and hurt my voice. Very, very simple to get this one wrong. Very simple for someone to come along and get it wrong. Right, anyways, so okay, we fixed all these things because now what they want is invoice printer, right? You have to create a printer to invoice print, which again may not be the worst idea because if you do this, if you do this, you can pass things around. It can be useful depending on the depth of your program, and so you kind of have to like determine how much do you wish to have. Now see, I told you they'd pull out save file too. Now this, on the other hand, now you're starting to get to the point where maybe not sure, right? Maybe you should have. Maybe you can make this completely different, right? Maybe you want to save this as a JSON, and so you just want a JSON encoder. I already hate it already. The problem is that anytime you want to see where something has changed, you have to hop all over the place. And that's like my big contention, which is locality of behavior. So for me to understand how this thing works, I can almost understand how the whole thing works within a single screen, right? We can understand every part of what's going to happen in the interactions. This, on the other hand, I have to go find this. I have to go jump to it. I have to go because it's not going to be contained within the invoice. It's going to be contained somewhere else. I have to be able to look at this one and go find the exact same thing. Like I have to go look at it. But isn't that limited to smallish systems? That's if you have it's not limited to the size of the system. See, that's the problem is that's one of those classic like oopsie daisies people make. This is not a system level thing. It's a variety level problem. Now, if I have to print to a TUI, print in Vim, and print to a file, and print to just standard out with no TUI, can we all agree that maybe we're going to want an abstraction on the print level? Yeah, we would want an abstraction given to the print on that level. If I need to create also HTML for an HTMX endpoint, yeah, we're going to probably want some various differences between them. But that's different. Right, that's very, very different. Then you're going to have to use interfaces. You're going to want some way to kind of abstract it out. That's just different, and that's okay. But if you only need to do one kind of printing, like why are you planning on more printings? Like until you can prove to me. So I like Go's argument of this, which is you abstract when you realize the abstraction. I think that is the better one. So in other words, or they say it this way, you abstract when you discover the abstraction. You don't abstract before you start. You abstract when you need it, like when it's time. Why is that Go specifically? It's just one of the mantras of Go, right? Because Go is such a simple language, it kind of forces you to like think in very simple terms, and so. Typically, whenever you see people that write a lot of solid, they start out with interfaces. They start out with these ideas. Whereas I would say don't start off with interfaces. Go pure concrete until you need an interface. All right, open close principle. This one requires that classes should be open for extension, closed to modification. Modification means changing the code of an existing class, and extension means adding new functionality. So what this principle wants to say is we should be able to add new functionality without touching the existing code for the class. This is because whenever we modify the existing code, we are taking risk of creating potential bugs. Well, I mean, adding new features, you're also creating risks. I'm not convinced that there's any less or more risk in that statement. We should avoid touching the tested and reliable, mostly production code if possible. I mean, but you add new code, you do have the exact same chance for bugs. But how are you going to add new functionality without touching the class, you may ask? It is usually done with the help of interfaces and abstract classes. See, you reach for abstraction first in this. More regression risk, probably. Yeah, but then you just have more new bug risk. Right? Like, you're not changing the equation. If I have to add, a chunk of code, and this intersects some level of existing code, right? I'm not convinced that more intersection or less intersection makes this more or likely for bugs, right? Like if I just have to add this, if I'm going to write a bug, I'm going to write a bug. There's no avoiding that idea. All right, let's say our boss comes in and says he wants invoices to be saved to databases, so we search them easily. We think, okay, this is an easy peasy, boss. Yeah, again, I probably wouldn't even save them to file. Honestly, I wouldn't save these to file just to begin with, because I think saving to file is, I mean, what would be the point of doing this, right? You have to be able to ask yourself why you'd want to do this. To me, this is like a test harness code. You'd want to pull out, and you'd only want to be able to like load up a database from file. Really, would you? If you're using SquealLite, you can just have your database as a file, and bada bing, bada boom, you already have a golden. We don't call them bugs. We call them unexpected features. Yeah, Fortnite rocket riding was an unexpected feature. Let's see. So a lazy developer, let's see. So as the lazy but clever developer for the bookstore, we see a design problem and decide to refactor the code to obey the principle. Save, invoice, interface, save. There you go. So you again, I don't actually disagree with this idea that you have to go through and you have to make. With this, like this is fine. This is literally just so if you, for those that are wondering, this is literally just the strategy pattern, right? Strategy pattern is pretty much in every single language in every single way, and it's very, very simple. All you do is have an interface with concrete implementations, right? Fantastic, right? We all use this in one way or another, right? There you go. Bada bing, bada boom, beautiful, beautiful. Now our persistence logic is easily extendable. And if our boss asks us to add another database, we have two different types of databases like MySQL and MongoDB, we can easily do that. True, but then now you start getting into this thing, right? Persistence manager that takes in an invoice persistence and a book persistence. And now you start having these like aggregations of super classes. And you have to ask yourself why. Why are you doing all this? What's the purpose, right? What is the purpose of adding this much classes to do that? The purpose is Gillette, the best a man can get. Yeah. Liskov substitution principle. The Liskov, I've read this. I always forget what this stands for. States that the subclasses should be suitable or substitutable for their base classes. This means that given that Class B is a subclass of Class A, we should be able to pass an object of Class B to any method that expects an object of Class A, and any method that should not give. So I generally just think that inheritance makes things hard to think about. The problem with this is that anytime you have the hammer of inheritance, you often have it overused. It's extremely difficult to use inheritance well. And I typically find that I can't use it well. I want to be able to use it well. Every time I use it, I regret using it. Every time you have the hammer of inheritance, you end up getting nailed. Like, I'm sure there's some really great things for inheritance, and I know some people talk about some versions of game programming inheritance is often used and it's really, really great. I just can never seem to get there. Can we stop pretending that OO is hard? Can we just stop pretending that OO is hard? No one's pretending that the base idea of OO is hard. It's that if you have a large implementation of OO, it can become quite the most annoying ass thing you've ever worked with, because then you start getting into these huge problems with base class and extending classes, and then you end up changing both of them to make things continue to work out. Forcing things to work together is just a complete pain in the ass. There are better ways to go about a problem, and I actually have a really great example. I'm just going to have to redo the example. I'm going to have to think really hard about it. But Netflix, Skunk, no, it's not Skunkworks. It's I knew it was Skunkworks. See, I was saying the word Skunkworks. I knew it was in there. So great example of something is implementing this. I've implemented this. Man, do people want to implement things with objects, with classes? So much better to go flat objects and go with mutating functions. So much better. All right. So, anyways, all right. So Liskov, I'm just generally not a fan of Liskov. I find everything that Liskov says to do is implying that you want a lot of inheritance. And I just always find inheritance, just no matter what, ends up being just an emotionally painful experience. You know what I mean? Because every gosh dang single time, right? It's just very painful. This is going to be squares and rectangles, which again, this example is entirely too simple. Of course, squares and rectangles. Squares is just enforcing something right here, right? It just enforces that width and height are the same, and then blah 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 blah, and that's that, right? Okay, super simple. I get it. You can do all that. Fantastic. Super simple example, but that doesn't mean it's actually simple, right? It doesn't mean it's actually simple. It doesn't actually become simple. Now, I know that like some people are going to be like, well, have you used a Java standard library? Like they have really great lists and all that. Yeah, it's like okay, but it's really not that okay. when you start looking behind the things and you're just like, wow, this is not that great. This really isn't great. Fake legs confirmed? Yeah, I know. Fake legs confirmed. We were actually going to name the podcast not Hack and Stash, but No Legs and Stash. But he didn't like the name. Okay. Interface segregation principle. Segregation means keeping things separate, and the interface segregation principle is about separating the interfaces. The principle states that many client-specific interfaces are better than one general-purpose interface. This is actually a pretty good principle. This is also in Go, which is keep your interfaces as thin as possible. Don't make it a lot, right? Make it as small as possible, right? And so the bigger your interface is, the more things that have to implement it, the more specific your interface is, which means the less useful your thing is. So we're gonna, we can go through this, right? Which is you could imagine that you could capacity doesn't have to be related to some things, right? So that's like why IO Writer and IO Reader are so nice. It's just a singular method. And so implementing an IO Writer is really simple. You don't have to worry about closing. You don't have to worry about all the other things that probably do go with file handle operations or with TCP endpoints or with your own bespoke, your own bespoke encoding algorithm. You don't have to worry about any of that because it's just here's a really thin, tiny interface. Just implement that. So it's very, very good. So I agree with that one. I typically agree with this one. So not the I of in solid is pretty good. I'm a classic I enjoyer. Okay. Dependency inversion principle. The dependency inversion principle states that our classes should depend upon interfaces or abstract classes instead of concrete classes and functions. This is also fairly-ish Go. Typically in Go, you return structs, you receive interfaces. Typical, that's considered a pretty good rule of thumb. And so this one is not necessarily bad. The dependency inversion principle states that classes should depend upon interfaces. Yeah, again, I think that, return structs, receive interfaces, very, very good. When you return interfaces, that's a rarity in Go. Every time that I've done that, I've never really voiced it that well as they do in Go, but it's always been kind of this intuition that always can be really, really, really annoying. Right? It's good for testing. Exactly. That's why interfaces are considered better, is because you can easily just hand in something that adheres to the interface. That's why something like structural typing can also be really nice, just because you can just implement the interface without explicitly stating it. So Java, you have to say what you implement, whereas in Go, you just implement, and if you happen to structurally match, you're good, which I think is really nice. If the OCP states the goal of OO architecture, the DIP states the primary mechanism. What's the OCP? What's that one again? Which principle is OCP? What's the O in solid? I think it's the one I hated. Open close principle. Yeah, open close principle. I hated that one. That's my least favorite one. The two principles are indeed related, and we have applied this pattern before while we were discussing the open-close principle. We want our classes to be open to extension, so we have to reorganize our dependencies to depend on interfaces instead of concrete classes. Our persistence manager depends on invoice persistence instead of the classes that implement that interface. So the big problem with this is that you always know that an invoice persistence then the persistence manager then needs to become abstract after a little bit of time, because the persistence manager needs to be able to manage persistence of a bunch of objects. So then you literally have just 3-4 layers of abstraction to save 3 separate items. You know that once they add a third one, you have this entire experience of okay, well now we're getting too many little, properties. We need an array of these things so that we can abstract on it, and they all need to do this. And man, it is just it just keeps growing. It's this ever-growing abstraction, which just takes much, much longer for you to understand why something is. I'm not even against abstraction when it's good. Conclusion. In this article, we started with the history of solid principles. Yes. Oh, you're telling me what we already learned? Okay. No, what's the conclusion? Tell me the conclusion. You know what? I am not a fan of saying what you're going to say it, saying what you said. I'm not a fan of that. I think the conclusion should just be give me the meat and give it to me raw. I want to thank you for taking the time to read this. I suggest keep the principles when designing, writing. Okay, so here, I think this should be the conclusion right here. I suggest keeping these principles in mind while designing, writing, and refactoring your code so that your code will be much more clean, extendable, and testable. I think that you also abstract for the idea of extension before you need extension at all. And then guess what? I think that you're a sad, 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 sad person. Okay, so like in my brain, so just to be fair, just to tell you where I'm going in my head. So we've been designing this nice little game engine, and I realized something, okay? I realized something very, very important, shall we say. I can take our little game engine, and the difference between, say, rendering it in NeoVim and rendering it just, say, in Charm with SSH is not that much, right? We can actually do that. I'm just going to have to make a small front end that takes in an SSH connection and writes it out to the SSH string. It's actually not that hard. Should I pre-start planning for that to happen? No, I'm not going to. I'm going to write the thing and do the thing. You know what I can also do? I can also use HTMX and server-side events, right? Server events, and actually get that thing where I actually open up a connection, leave it open, and send down events, and I could have the exact same experience. You'll be able to watch our tower defense game in the browser via HTMX. Or I could even upgrade it from server events into WebSocket events. Not hard to do. But that's all watchable, and it's all doable with the little game engine we're building. But here's the kicker. I'm not trying to just immediately interface out, fully knowing where I was going. I did not try to make it that abstract. And I think that's good. I think that's a good way to go. I knew an abstraction might be needed, but I did not start with the abstraction. Instead, I started with the concrete nature of it, and we'll move on. Why not? Because when you start abstracting, you start making decisions for what the problem should be. Not what the problem is, what the problem should be. And that is truly like one of the greatest evils of software. And so I refuse to abstract to what I think I need. I will instead build the thing I know I need, then build the thing I know I need next, and go, what's the abstraction between these two things? Put them together and love it. And be happy with it. Because guess what? If you can make one really good one, and then you can make a second one that's really good, I guarantee you by the time you've made that 1 and 2, adding the third abstraction will not actually be all that hard, because you're like, we've done it. We've made it. I've already figured it out because I needed that renderer anyway. So now I have this nice little rendering layer, and now I can write the renderer that works for HTML as much as it works for Charm 2es, right? The name is the Primogen.